All right. Yes, thank you for the introduction, and thank you for the invite to come and speak about biodiversity, which is, of course, one of my very favorite things to talk about. I think you had a really nice introduction there, and I'll expand a bit on a lot of the topics that you touched on, Marie. But I just want to get everyone pretty much on the same page for a little bit of what biodiversity is to set the framework for the discussions today. So, oh, and maybe I should introduce myself again real quick. I'm Allison Perrigo, as Marie said. I'm the director of the Gothenburg Global Biodiversity Center at the University of Gothenburg. And we're a group, we have 14 different partners around Western Sweden, and we work with biodiversity in many different ways, through research, through outreach, through community engagement. And a large part of what we do is trying to get people working with biodiversity to talk to each other a little bit more, because there's a lot of people working with biodiversity around Western Sweden, but they're not always in the same place at the same time. So we're trying to improve that a bit. And I think that's also a lot of what today is going to be about. So moving on, I'd like to start with your picture of biodiversity. What do you think of when you think of biologisk mångfald? What comes to mind? So I'd like everyone to just take a moment, not focus on their computer screens, close your eyes if you want, your camera's off, and think about what biodiversity looks like to you. What is the picture that comes to mind? What does it look like? What does it feel like? What does it taste like? What does it sound like? And kind of get that picture. Put yourself in a place that's surrounded with biodiversity. And now that you're there, pretty much anywhere you are is a place that is going to be surrounded by biodiversity. It's all life on Earth, past and present. So maybe you were thinking about a rainforest and you're seeing all the green leaves around you and the toucans and the birds and the monkeys. Maybe you were diving and you were seeing corals and fish. But biodiversity it's everything alive. So it's really, I promise you, from where you're sitting, you see some part of biodiversity, if it's even just looking back at yourself. So biodiversity is everything that's alive. But we're scientists, or many of us, scientists like myself, we like to measure things. We like to understand things in some sort of quantitative way. And for that, we need to measure it. And with biodiversity, it's a little bit tricky because unlike climate change, where you have a very discrete number, you can understand carbon emissions very concretely, biodiversity is a little bit more tricky. So I'm going to take you through a few of the different ways that we can measure biodiversity, because there's different ways to look at it. And depending on how you look at it, you will interpret it differently. So this is sort of the basics of this. And I know that a few of the speakers later will go into different ways that they're measuring biodiversity. So it's nice to see it in practice as well. So the three basic levels of biodiversity are genetic diversity, and that is the diversity that we see within a species. How is its DNA different to other DNA within that same species? And genetic diversity is important because this is what gives a species resilience. When you have too little genetic diversity, you can get into what's called a population bottleneck, and a species can be very vulnerable. If something bad happens, it can't respond very well. The next level is species diversity. And I think this is probably the level that most of us think of biodiversity at, is how many species are there? These distinct units that we can understand. This is a snake, this is a frog. So understanding it just in the sense of this is how many species we have that's a good way to look at it as well, although it doesn't take into account everything. And then the third level, if we're moving up the ladder, is ecosystem diversity. And this is when you can look at a place, wherever you are. If you look at these three pictures, you might immediately notice that there's a lot of green and then there's a blue sky. And that's, you can see they're different ecosystems. They look sort of fundamentally similar, but you can tell that they are made up of different organisms that are interacting in different ways. And I think that this is a good place to start, because you see this landscape, but then if you move a little bit closer, you can see, yeah, there's different species, different plants, different insects. There's different stuff going on there. And you might even be able to see the genetic diversity if you get even closer. I would bet that a lot of people here have been out behind their summer home at some point, laying in the grass looking for a 4-leaf clover. And that's a good example of genetic diversity, as the 4-leaf clover is going to be a little bit different to the 3-leaf clovers. It's got a mutation going on there. Then we can think about biodiversity in some other ways. And there are many different ways to think about it, but I want to introduce 2 more here. The first one is functional diversity. And this is what is actually, what a different organism is doing within its habitat. And in this sense, not all species are equal. We can look, for instance, at the Hawaiian hiney creepers that I have the image of here. And you can see that there's some that are more adapted to sipping nectar, some that are more adapted to probing insects, for instance. And they look different, and they play a different role in the ecosystem. So if you lose a species, if a species goes extinct, it's going to have a different effect if you lose all of the insect eaters, as opposed to losing one of the nectar sippers and one of the insect eaters, because you'll still have redundancy within the ecosystem if there's multiple ones doing the same thing. Likewise, you can think about in the ocean, I have my picture of the white-tip shark there. You think about sharks, or maybe about whales. Whales are really important for nutrient cycling, because they go up and down in the oceans. And when they go up, they defecate, and that puts a lot of nutrients in that then fall down throughout the ocean and affect a lot of other organisms. So if you lose a whale, it's a little bit different to losing a deep sea worm, for instance. So yeah, it's important to think about biodiversity in the sense of what the function is of different things within the ecosystem. And the final way that I like to think about biodiversity, that I think is the best way to look at it for us as humans, and maybe the best way for us to relate to it, is in the sense of biomass. And biomass is, it's how much things weigh. So how heavy is everything? And I really, really like these graphics from The Guardian a couple years ago, and it's based on a paper that was published in PNAS the same year. And it's looking at the biomass of biodiversity. So what do we have on Earth? And right now, as you can see in the figure here, over 80% of all of the life on Earth is plants, which is it's an interesting thing, because I think when we think of biodiversity, our minds maybe immediately go to elephants and rhinos and cats and dogs. But the vast majority by weight is plants. Then is bacteria, also probably often forgotten, but very important. 5% is all other, and we are just a tiny, tiny little sliver of what is in that everything else. That biodiversity is not evenly distributed. The oceans make up the vast majority of the planet, as you guys know, but most biodiversity is actually on land, if we're looking at mass. So 86% of all biodiversity is found above the water. And so we can take this a little further and then look at, so there's the biodiversity that is sort of occurring in nature, and then there's agricultural, the agricultural animals, the things that we are producing for our own consumption. So if we look at this, this is kind of, this is a good take home, I think. Of all the mammals on Earth, so dagdjur, 96% are livestock and humans. So of all of the mammals, 60% of them are livestock, mainly cows, which is pretty crazy. And then in the bottom corner, you can see there 4% are wild mammals. So that's the elephants, that's everything you see on safari, that's the monkeys, the pangolins, that's everything else. But cows are way, way, way more. And there's also a lot of us, which I think most people are aware of. This trend we also see in birds. So 70% of birds are chicken or poultry, so things that basically birds that we will be eating, and 30% are wild. And these numbers are, of course, there's two things affecting this. It's both that we are breeding a lot of animals, so we are increasing the numbers of the animals that we are eating, and then we're also decreasing natural populations, also significantly in the last years. So, yeah, I think it's really interesting to think about that when you go out into nature. What is nature, and how is it actually distributed around the planet, and how is it made up sort of between the wild things and the things that we are influencing more heavily. But if we look back at species numbers, which is maybe the most common way of talking about biodiversity, there's close to 9 million species on Earth, it's estimated. Of these, again, we see a land dominance, 6.5 million on land, 2.2 in the water, more or less. This is obviously estimations because we only know about 10% of those. There's only scientific names for about 10% of those, which means if you go outside and take a handful of soil, handful of dirt, I promise you, you are holding new species in your hand, which is a fun thought, I think. But of those, it's expected that 1 million of them are threatened with extinction. And this is from the EPIS report. So this, we hardly know what's out there. And of what we know that a massive amount of it is threatened due to human activity. And this is happening very fast. So why should we care about this? I like to think that everyone here cares to some degree because you're all here, which is a fantastic first step. But there's really different reasons to care about biodiversity. And this is even within scientists, within people who really have a strong desire to protect it. There's different rationale behind it. And this is something that needs to be evaluated at a personal level and at higher levels as well. So I like to break it into two general categories. And of course, there's a lot of nuance within this, but in general, most people think of nature as biodiversity as important, either because of its contributions to people, also sometimes called ecosystem services. So what does nature do for us? We should protect biodiversity because it does something for us, and it definitely does a lot for us. The other reason that a lot of people motivate it is that biodiversity has an inherent value, that we are no more special than the other 8.99999 million species on the planet, so maybe we should just let it be. And your reason for caring about biodiversity may fall anywhere between these, include both of them. But I think it's good to reflect on why it's good to keep biodiversity. And I just want to touch briefly on this report by Diaz et al. In Science last year, which was the scientific follow-up of the EPIS Summary for Policymakers. And this is a line out of the first part of the report that says, the capacity of nature to support quality of life has declined for 14 of the 18 categories of nature's contributions to people considered by EPIS. So this report is it's worth reading. It outlines a lot of the contributions that nature has, and it also outlines the current situation really nicely. So the reasons to care are why you value biodiversity is one thing, but it's important to think of how how we're changing it, and how quickly it's happening. And then this is in the lead into that same article in Science. And it says, for decades, scientists have been raising calls for societal changes that will reduce our impacts on nature. Though much conservation has occurred, our natural environment continues to decline under the weight of our consumption. Humanity depends directly on the output of nature. Thus, this decline will affect us, just as it does the other species which we share this world with. And this, I think this is the reason to care more than anything, is that now is the time. There's a lot of change going on very quickly, and the sooner that we do something about it, the more we're going to save. So it's really an issue where time is of the essence. And then I'd like to finish up with what to do about biodiversity loss. And I'm not going to tell you what to do because I don't know that. That's a very big question and very specific. But I do want to talk about this in the sense of framing how we're going to do things and how we should look at the problem. So I think the most important thing that hopefully can come out of today as well is understanding the problem with biodiversity in order to find solutions. And this is, I think about biodiversity in the sense of a leaking bucket. We have this bucket and it has all of biodiversity in it, and it has these holes in it. And these holes are caused by human actions. It's normal to have a tiny little drip. Like normally we have species going extinct and then it rains a little bit and we get new species. So there's this constant turnover, and that's normal. But these holes are getting huge because of the things that we're doing. So what I propose is that you think about biodiversity not in the sense of improving it or increasing it, but in the sense of not hurting it more. It's something that we need to think about. We need to think about how to not make this problem worse. And with that, it needs to be considered in the sense of what is driving biodiversity loss. Marie mentioned that it is not really the same thing as climate change. And I think that's maybe the first thing, is to understand that it's not primarily climate change, although that's part of it. There are other things that are the bigger drivers. So the largest driver of biodiversity loss, according to the EPAS report, is changes in land and sea use. Over 70% of Earth's non-ice surfaces are exploited by humans in some way, and that has a huge impact on biodiversity. If you think about, like a lot of us think about climate change is bad for biodiversity, but if the rainforest is cut down, it doesn't matter what temperature it is, right? There's nowhere for things to live. So changes in land and sea use are the biggest driver of biodiversity loss right now. The next is the direct exploitation of species, which is going on very, very quickly. Number 3 on the list is climate change. So that is also having a massive effect on biodiversity and should be considered, but it is definitely not the only thing. And then we have pollution and invasive species are the 4th and 5th largest drivers of biodiversity loss. So if you want to do something about biodiversity loss, I would suggest that you start thinking about how to plug these holes. How can we stop changing so much how we're using land and sea? How can we stop directly exploiting species? How can we slow climate change? How can we decrease pollution? And how can we avoid invasive species? So that, I encourage you to frame your thinking in that sense. And then finally, how do we integrate it into our sustainability plans? And again, different people, organizations, regions, and countries, everyone impacts biodiversity in a different way. And so it's necessary to reflect a bit on what is your biggest impact and how can that be addressed, because it's not the same answer for everyone. We need transformative change. We need something big and drastic to happen, and we need to do it together. We need to do it at different levels, but we need to do this very quickly because we're losing a lot in a short amount of time. And then explore, learn, network, and act, which again, I think everyone is here to do. So I think that's a great way to take it forward today. And finally, we've all seen the SDGs many, many times. You may have seen this figure as well. And I like this one because it shows, instead of having all the blocks laid out in this nice order where they're all equal, this one shows that they sit on each other. And fundamentally, everything sits on the biosphere. So biodiversity goal 14 and 15 form the basis for a lot of the societal and economic goals. And we have this, I have this arrow here, it's going to society, it should also be going to economy. Biodiversity affects both of these, like all of these goals in some way. So it's giving something to them. But even more so, society and economics are impacting biodiversity. I would argue that the impact that they have on a biodiversity is a lot higher than what biodiversity is giving to them. So I think that there's a responsibility here to understand that our actions are very heavy on the natural world. And with that, I would like to say thank you. I'm looking forward to the discussions later on today. And yeah, thank you again to the organizers. I know you guys have been doing a lot of work leading up to this. So yeah, thank you for all your hard work, and thank you everyone for listening.